Welcome back to Chapter 1.2 Writing Rational Numbers as Decimals from Course 2A of Singapore Math. Well, this video is for explaining concepts and make your life easy. In this chapter, I will explain you all the concepts that you need to know to solve this chapter with full confidence and get all answers right. Let's get started. As you can see, this chapter has only three things to understand. It's about writing rational numbers as decimals. So it's basically about divisions. First thing is terminating decimals. So when you do the division, it ends. Let's understand terminating decimals with the help of an example, as examples make understanding much easier. 1 over 4 is an example. How do we divide this? We know the answer already for this, but we are going to use long division. Let's write this. We write 1 inside like this and 4 over here. Now 4 does not go in 1. What do? We write extra 0 here. But when we do that, we have to be careful, remember, and make a decimal here. Then 4 goes in 10. It goes 2 times, and that is 8. So 10 minus 8 is 2. Remainder is 2, right? You put another 0. Now when you put 0 next time, like it's when you put 0 for the first time, the decimal is done. This decimal here. When you put it again, you don't need to put decimal again and again. It's done only once. Now 4 goes in 20 by 5. So 4 times 5 is 20 and the remainder is 0. Do you see? It terminated. It ended. There is no going on and on and on. So the answer for this is 0.25. So that's how you do long division. So whatever your numbers are, you will be able to do this easily if you know your times tables. That's how this part is done. Now let's do the other one, repeating decimal. See the difference? Terminating and this one is repeating. The process is the same. The only difference is this is not going to end. It will keep repeating itself. Let's understand this with an example. 1 over 3. Yes, we are going to write 1 inside and 3 here. 3 does not go in 1, so we write 0 here and a decimal. Yes. 3 times 3 is 9. Remainder 1. I'm going to write 0. Now do you see the 10? Again, it's coming. So again 3 times 9, 1. Again this pattern keeps repeating. So my 0.333, it will go on. So the answer is going to be 0.3333, never ending. It's repeating. So the process is same. It's just that it's repeating. So my answer is going to be 0.3. And I'll put a bar notation here indicating that this digit keeps repeating. For example, if your answer was something like 0.2345345, for example, it's just an example. Do you see this digit 2 does not repeat? So how do we write this? We are going to write this as 0.2345 and a bar on only 345. So this is how long division is done when you have repeating decimals. Now we come here to the middle part, comparing rational numbers. For us to compare rational numbers, we need to convert them in a format that's easier to compare. For instance, let's say our numbers were 1 over 4 and 1 over 3. How do we compare them? They do not have the same denominators. In that case, we are going to convert both of them into decimal numbers first. I've taken these fractions purposely because I know my answer from here and here. So 1 by 4 is 0.25 and 1 by 3 is 0.3 bar. Which number is bigger? We are going to compare the first place after the decimal. This is 2 and the other one is 3. Then of course, this is the answer. If that's the case, this will also be true. What if it was 1 over 4 and 1 over 3 both with negative sign? What's my answer? 0.25 and this is 0.3, both with negative. Now we know when we have negative numbers, the rule changes, right? So here, minus is going to be greater than this number. So remember, the positive and the negative sign associated with the numbers makes a huge difference. So you have to be very careful in looking for this sign. If you had missed this negative sign, you could have written this way and that would be wrong. So looking for the sign is very important. We will say 1 over 4 and this is minus 1 over 3. But obviously positive number is always bigger than the negative number. So this is how you compare them. And if you want, you can also see on a number line. Let me just draw a number line here, a random one. That's 0, that's 0.1, 0.2, 0.3. Now 0.25 has to be somewhere here and 3 will be somewhere here. So you can see this number is smaller. If it was minus, same thing we do here, 0.1 with the minus sign, 0.2 with the minus sign, 0.3 with the minus sign. Now minus 0.25 somewhere here and 3 would be somewhere here. So here in this case, this becomes a bigger number. Okay, so even using number lines, you can confirm your answer. So this is how this chapter is done. It's about division, basically. Knowing how to do this long division is what this chapter is about. And you get your answer. When it's terminating, it ends. So you don't need to worry about bar notation. When it's repeating, you have to decide where your bar notation will be, only on the digits that are repeating, not the ones that are not repeating. So the pattern could be the same digit. In this case, as we had 3 repeating, but here it's not just one digit. There are 3 digits repeating, 3, 4, 5, 3, 4, 5. That's the pattern. So you have to watch out for the pattern and put your bar notation and compare. For comparing, you have to convert them in a format that is easier. So here I converted them into decimal numbers and then I compared. While comparing, watch out for the sign of the numbers, positive, negative. So accordingly decide which number is larger, which number is smaller. And this is all about this chapter and you're done. Do watch out for the independent practice and do it confidently. Bye-bye.